3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Hey, space enthusiasts. So, 2 episodes ago, I did a quick overview of space stations. On this episode today, I'm actually talking to a space station startup called Think Orbital. They're proposing an innovative technology solution to build bigger stations and lots of them. I discuss all of that with the co-founders, Sebastian Asprella, the CEO, and Vojtech Holub, the CTO. Enjoy. If you like the podcast, quick reminder to please leave us a review or rating on your favorite podcast platforms, such as Apple. Thank you. And as always, here are a couple of short messages from our sponsors, and then please enjoy my conversation with Think Orbital.
My name is Raphael Rodkin, and I'm an investor and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by NanoAvionics, a satellite manufacturer and mission integrator. Their technologies enable many space companies worldwide to offer services that improve life right here on Earth, such as providing global connectivity, conducting Earth observation, or contributing to scientific discoveries. Check them out, and also check out my episode with the CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University. ISU offers a number of educational programs about space worldwide. Check them out at isunet.edu.
Well, hello everybody. Today I have Sebastian and Vojtech here from Think Orbital. Welcome, guys.
Hi, Raphael. Thanks for having us.
Sebastian is the CEO and Vojtech is the CTO, and they're both co-founders of Think Orbital, which is basically a company pretending to build space stations. But tell us more about it. Give us the elevator pitch.
Yeah, not far off, Raphael. So the way we see ourselves is a foundational company for the new space nascent economy. And effectively, you could see us as a real estate operator. So infrastructure builders in space. We do have our Halo product, which is the Orb-2, which is a single launch, self-assembled, eventually autonomous space station. And what we're gravitating towards is to have also non-human rated as well as human rated activities. So if you can imagine, if somebody would need some form of storage in space, or maybe a place to put their computational power, or some sort of infrastructure for manufacturing, that's where we come in. That's our core business model, to be able to facilitate other companies, or basically a space platform for where everything else gets built on.
And so how does one wake up? I mean, I have many people on this podcast, right? And I ask this frequently. How did you wake up and you decided, to build a satellite constellation or a rocket? But I mean, space station seems to be a different level. How did you guys wake up and decide to do a space station?
I was kind of looking into the industry and asking myself, it's like, how does the industry accommodate to the new capabilities that are coming to market, like the Starship or New Glenn? And I couldn't see anything, and that got my mind spinning. And at some point, I was thinking, well, perhaps humans can do like a dumb satellite, something that would be not so mass optimized and could be made much cheaper, or potentially building space station that could be assembled in space and create even larger volumes. And as my mind wandered, I came up with this idea for assembly and get it refined over time, going to conferences, publishing papers, and nobody could tell me why this wouldn't work. There was only one thing left to do, and that's when we met with Sebastian with his business development skills and project management skills. And I'm more of an engineer. So at that point, we started a company, because if no one is doing it and no one can tell me why this cannot be done, that's the next step.
And I guess that means until today, nobody has convinced you otherwise, by definition, giving you a good counter argument.
Well, we had so far just under 130 discovery calls, and one of them earlier on was actually with you, Raphael. And it's true, we've not been told we cannot do it, but everyone's been so supportive and so excited, to the extent that I would say almost every single call, people came up with a new idea on how we could use this. So it's been really fascinating, and I think the whole space industry is very supportive of each other. I think we all have this sort of vision of giving broader access to humanity to space and so on and so forth.
So let's pick up on that. It's basically the use cases, and you started mentioning it a little bit in your elevator pitch, but let's go a little bit deeper. So where do you see the main use cases for a station? And also curious to hear, so both in the near term, and then as well, maybe some sort of like funkier stuff that maybe people are not thinking about that much yet that may happen in the medium or long term.
Well, we're looking about 6 different markets. And I have to emphasize that our core business model is in-space assembly. And that's where we want to focus on. And this is why, we want to be able to support other companies, be it Action Space or even the guys that are doing Orbital Reef or Starlab, as well as many, many other companies, to be able to come in and augment their product offering. However, when we look at the markets and where the sort of space economy it's moving towards, well, the first one, as I said, is in-space assembly, but also why not, storage, fuel, and also servicing as well. We are talking to some great companies out there. You have, for example, Orbit Fab and many others that are trying to really expand the potentials around even servicing as well. Then they have the classical research and manufacturing, like we've seen, for example, in the ISS. And I think those are some of the core capabilities that we see also when it comes to Orbital Reef, Starlab, and Northrop's space station. Then moving on also within the scope of what they're doing could be also in-space hospitality and tourism. And for some of the use cases that I'm mentioning now, or the markets, we already have done, for example, the architectural design. We have done some of the costing, not necessarily because we want to run them ourselves, but because we want to show our customers or customers of our customers how this could look like, give them some sort of immersive experience. Then moving into the future, we're looking at space resource capture, which is one of the key theses of so far our largest prospective investor. Kind of more science fiction than fact maybe today, but to facilitate mining of asteroids, or why not mining on the surface of the moon? And in a way to tap into all of those resources for key rare earth metals that are needed here on Earth, and at the same time lift off what otherwise are very, very pollutive type of industries. And last but not least would be some sort of surface application or orbital application around Mars. Imagine a situation where we master the assembly technology, and we're able to send, before we send a human crew mission, we're able to send this far out, be it assembled, and it could be used either as some sort of refuge or a forward station for when the humans arrive. Then they have a place to be before perhaps they go into the surface of Mars. But this is more science fiction than fact. Is more out into the future.
So I want to add, what really differentiates us is the capability to create large volume in space, which is enabled thanks to the assembly technology. So imagine what you could do with volume that you can put up with a single launch. We are talking about 2 to 4 times the internal volume of the ISS, depending which vehicle you design it for. The imagination can run wild. Like, if you have so much volume with a single launch, what could you do with it? And everyone that looks at it has different ideas how this can be utilized, which is kind of a blessing and a curse at the same time, because you talk to 10 investors, to 10 customers, and they see 10 different opportunities.
But could you not run into the same issue that you have with some other, aspects in space, for example? Like, the question that always comes up about the moon is like, okay, what's going to be the first killer app for the moon? Is there potentially a different problem here? So like, okay, what's the first killer app for space stations, or is it as simple as tourism?
This is what we're exploring at the moment. So we have a pipeline of customer discovery exercise. We do have some level of understanding, but I think more research is required in terms of what can we find on the surface of the moon, and what in a way could help not only things, markets that are perhaps mature here on Earth, but also how can those facilitate helping the space economy grow and flourish. And some of the materials could be used also for further assembly in space, but we understand that some of the resources could also be used for fuel. So these are the things that are fairly early stage, but we're looking out. We have a roadmap all the way to 2069. And obviously, as you go far into the future, as I was mentioning earlier, it's more science fiction than fact. But we do try to capture all the feedback that we get from potential customers, also collaborators, and then follow through from the beginning to the end. Sort of try, test. If it works, carry on, and then deliver maybe some white papers on 3 of the business models.
Hang on a second. Did you say you have a roadmap out until 2069?
Yes.
Okay, so sorry, I got 2 follow-up questions here. One, why 2069? Is that just to possibly please Elon because he likes 69, or there's some other reason behind this? And then the other question, of course, is what is at the end? What happens in 2069? What's the end point?
No, that's great. So there are 2 things. Indeed, the 69 with Elon, which I have to put out. I'm an Elon fanboy. I have no shame in saying that. And the other thing is, 2069 will be 100 years since we set foot on the moon. So for us, that is quite a milestone in itself. And what we tried to do with the team, which were a diverse team, we're 16 currently, plus 5 outstanding advisors. We come up with ideas in terms of what could use the org2 for, or the assembly process. We have also, as I said, customers, and we don't want to necessarily trash any idea unless we think it's impossible to set out. And we try to put them in line with, what is the technology that is readily available, how much of that technology has been tried and tested in space, how can we combine some of our innovative technology to be able to satisfy those needs. And then based on that and based on the market needs and so on and so forth, then we set out this plan, which starts first. Well, we have a demo flight in early 2024, but really the product that we're looking at will be in 2028 to satisfy some of the LEO needs as a space platform. And these are some of the ones that I mentioned earlier. I can go in details. Then move into GEO, then move into orbit around the moon, then some sort of surface application, then look at the potential resource processing and utilization of asteroids. And that's when you start getting really far out into the future at sort of that stage.
I think we are definitely focusing much more on the next few years. But that being said, going back to the moon, even though we don't have any clear business plan and no one knows what's the killer app for the utilization of the moon, having the assembly technology that allows you to build things in space also allows you to build similar things on the moon. And once you add to the fact that the structure is made of aluminum, and that's one of the things that moon has a lot of, you can see kind of the future opportunities that go more into the science fiction, but definitely it's a viable thing.
And so strategy-wise, so you guys at the minimum are building the platform, right? As you said, like sort of in-space construction company, right? And then you can kind of go from there. Are you going to stop there, or are you going to also operate the platform and maybe exploit some of these use cases yourself, right? Because this, again, is a question that's relevant for some other business models in space as well, right? We come across this discussion very often when, for example, we're invested in space manufacturing, right? And so there's also a question, do you just provide the ability to manufacture, or do you actually at the very beginning have to do some of the use cases yourself to get the whole thing started? Kind of like, in the same way that, Apple, when they put out the iPhone, they kind of help put out the first few apps themselves just to kind of get the whole ecosystem started. How are you guys thinking about this sort of like strategy-wise?
Yeah, that's what we may have to do. So again, I keep emphasizing our core business model is to assemble things in space, infrastructure, like a real estate operator in space. But what happens if the market, by the time we get there, is not readily available? So we're looking at a second or third business model where we may be able to tap into some existing market here on Earth that would generate some of the revenue going forward. I think not dissimilar. Also, you mentioned, I think Apple is a great example. Also, you look at SpaceX, where they have launch capability, but also they have internet provision. Mm-hmm. However, and this is why we're looking out and we're having conversations with some other startups and some other companies as well. If we're able to choose, we would rather focus on our key business model and support those companies that want to manufacture in space, or need storage in space, or need computer capabilities in space, or fuel, so we can concentrate on what we think is our kernel technology.
That being said, if we are technologically ready, we would love to do space tourism, because that's the only market that's kind of proven and that can be definitely profitable, and you can look into the past at how much did the space tourists pay and what's the demand. So that's kind of one of the few markets right now that could be directly profitable, and Axiom is pretty much going in the direction. However, it's also the one of the kind of technological and process-wise most challenging applications, because you have human occupation with untrained people. So in that case, it's kind of on the end of the pipeline of what you could do if you had space in space. So we are looking more into kind of non-human rated applications first.
The tourism one, just to stay on this for a minute, it's kind of interesting, right? Because as you guys said, you have sort of multiple times the volume of the ISS, and then on the ISS, obviously a lot of space is taken up by glove boxes and sort of like other sort of experimental equipment, right? Which of course you guys will also have life support systems and everything that's going to take up some space. But sort of, I think your net space, if you build like a tourism-focused space station, what you call the orb, right, would be quite a bit bigger than the ISS, right? So does that bring up sort of the interesting possibility of what could you do with that tourists can't do on the ISS or Axiom even?
Yeah, absolutely. So because of what that said, that was the first use case that we developed for the Orb2, and we have a 65-page architectural design document. We have three team members that have a space architecture background, and we have effectively a distribution in terms of the activities that you could do inside. We have even the detailed distribution in terms of the size of each one of the areas, and things that perhaps in the ISS are very difficult to get. It's a quiet area to be able to rest, because the dormitories, if we can call them that way, in the ISS, they're in one of the busiest corridors, whereas the distribution in the Orb2 would be the opposite end of the more busier activities. An Orb2 configured for Starship and in current architectural design, we're looking at about 47 crew members. And that would be distributed between, obviously, those leisure-paying members and then the servicing staff and some operational staff as well. But that gives you an idea of the difference in magnitude of internal space. And we have discussed also potential activities, and that's where the discovery calls are very useful on what you could do to be able to keep them in a way a safe environment, but that experimental or experiential activity, sort of being in space, orbiting Earth, maybe 6 to 10 days. I think at this stage, obviously you can do it in the ISS, and we just saw two gentlemen that went up to ISS now, but really to give that level of leisure experience as opposed to being in a research lab like the ISS.
Raphael, have you seen or read Ender's Game?
Yes.
So that's kind of a lot of people who saw it or read it. It's like, oh, you could do the laser tag in the large volume sphere. It would be amazing.
First thing you're thinking about is basically taking kids up there and having them like war game it out.
on an unserious note, but
okay, on a semi-serious note, connected, I guess I could see it. Okay, let's leave sort of the kids. And by the way, as you know, at the very end, we will talk about Sci-fi, and Ender's Game is an absolutely fantastic book for many reasons, including sort of theory of war. But sort of taking what you just said on a semi-serious note, I guess if you have all of that space, you could have a better gym than on the ISS, or even like some other sports activities, right?
Yeah, we would love to share with you the distribution. Exactly, you have a leisure, recreational, sport activities. There's so many different sections in the leisure type of Orb 2 that because of the fact that the ISS was not built for leisure, you cannot have it in the ISS. So even we're looking at a bar. I don't want to give too much away at the moment, but it really is a different level of experience. I imagine to some extent what you may be able to get in Orbital Reef or Starlight, sort of this next gen of type of space station.
Yeah, we'll talk about those additional like recently announced stations in a second. But let's actually come back to the technology, because you kind of keep mentioning the technology and assembly, and I just realized we actually have not talked about it. We should kind of talk about it at least a little bit. So what is the sort of special technology that you came up with that makes this large volume possible?
So what we are doing is we are taking two very mature technologies. Both of them are very mature on Earth. They are also tested in space, and combining them in a way that hasn't been done before. The assembly process allows you to launch your space station in not fully complete states. So imagine that you have a pressure vessel walls, and they are flat packed in the payload fairing of the rocket, which allows you to utilize more space and mass of the rocket. And then you launch it. You can imagine like sort of like IKEA flat-packed space station. And then you launch it, and then you have a robotic arm that can pick up the individual pieces, place them in the locations where they belong, and then we have a system of temporary latches that kind of align it together. And this way you can build up a spherical pressure vessel, but there is no strength or airtightness yet. It's just all aligned together and latched. And the second stage of the process includes electron beam welding, which is a very mature technology on Earth from 1960s. For example, the F-14 fighter jet wings were welded to its fuselage this way. And it's a perfect technology, kind of the potentially the best welding technology humanity has, but it has one big disadvantage, and that is it requires high vacuum to operate in. So that makes it very expensive on Earth and slow, but it's perfect for space. And in fact, it has been tested in space by Russia and Soviet Union. So when you combine these two, robotic arm and electron beam welding tool for the robotic arm, you get the capability of moving segments in space of the pressure vessel and then weld them together. And that's kind of the core of what we are developing.
Yeah, I was going to ask whether there was an in-orbit demonstration, but so I guess you said the Russians have, or the Soviets have done it. Have the Americans done it as well? And sort of like, what was the extent of these tests? Was it just kind of like putting two small pieces together for fun, or was there something serious and we can kind of check that it kind of held up over time, or...
Yeah, there's an interesting history to that. So NASA did zero-G in-plane tests. They were supposed to launch it, but for budgetary reason they didn't. So they instead convinced, I think it was shortly after the breakup of Soviet Union, to give NASA the welded samples that the Russians did, and NASA analyzed them. But what Russians also did, they had a handheld electron beam welding gun, and you have amazing pictures from Mir of like a female astronaut welding things during the EVA on the outside. It was purely experimental, but it worked. There is an interesting reason why robotic arms are better than humans for of all, they are more precise, but the electron beam welding at higher power, if you want to weld something thicker, emits X-rays, and that limits how much power you can operate by a human astronaut. But do it robotically, and you don't have these limitations.
Okay. Do you have any guess of why we have not used that technology more in space?
Talking to everyone from NASA, it's like, yeah, we've studied that, but we never launched anything. So I think it's more of a priority, kind of NASA prioritizing different things, and very often Congress in the US was not very inclined to do anything with assembly or refueling in space, but that is slowly changing.
On your sort of own technology roadmap, is there, because I guess these tests were probably a while ago, you're talking about Mir, is there something that, would you go directly to trying to build a prototype station, or is there some sort of like first IOD where you kind of, weld a few things together and see how that works?
Yes. So our kind of highest priority right now in our short-term plan is to for next 2 to 3 years is to develop and build orbital demonstrator and have a mission that would prove the ability to assemble and weld things in orbit. So you can think of it as a 1 in 10 scale space station that would do exactly the same job, and the orbital mission would be purely assemble, weld, pressurize, and then that's it. So nothing practical, just increasing the readiness level of the technology.
And then this is audio only, right? So you have this very nice picture behind you where you can actually, I think, see the sort of a rendering of an orb space station. And so first of all, it's a sphere, right? The core module is a sphere, and then you basically have sort of, I guess, a service module with the solar arrays and tucked on. And then the sphere, it looks like basically the way it works is it hexagonal elements are basically welded together.
It's a kind of Zuckerberg geometry. There is very many ways how you could do this. This one fit best with the kind of the size of the individual segments and the mass, but you can do it in different ways. But what we are proposing as the Orb-2 space station resembles to Zuckerberg. You have pentagons and hexagons put together. And spherical shape is generally the best shape for a space station, except it doesn't fit very well into a payload fairing if you want to launch it in a rocket.
Right, which is where the IKEA flat packing comes in clearly. And you're right. You say, okay, hexagons. Oh god, this is like math. That's beyond me now. But basically, you cannot do only hexagons, right? You have to throw in some pentagons. Okay, that's
right.
It's definitely beyond the scope of what we're discussing here. Okay, and so at the end of the day, I'm sure you guys have run some internal numbers. So I mean, obviously the ISS, which we all love, is famous for being probably one of the most expensive sort of like public projects ever. There's some numbers out there also on the other proposed space stations. But is this going to provide a material sort of cost advantage? Like just roughly speaking, is this going to make space tourism much cheaper?
This is what we're planning for. So if we were to take the Orb-2, and I'm jumping ahead now as a sort of leisure hospitality platform, our metric target is $500,000 per private space astronaut, and other various names for this, for a 10-day stay without the cost of launch. So you can see the difference. I mean, how much are the people paying now? Is it 55, 70 million to go up there?
That's with the launch. That's with the launch. I think there was this announcement from NASA. I don't know if that's still valid even, but when NASA opened up the ISS more to commercial activities, right, about 2 years ago, they actually published the daily rates on the ISS.
Yes.
They actually weren't that expensive. I think it was like $33,000 or something per day. And then for some reason, I think you actually have to pay extra for the internet per megabyte or something, which I don't really fully understand why they couldn't just throw that in. But anyway, it wasn't that expensive. The biggest part was the launch.
Yeah. So we looked at some of the numbers that came up, and they seem quite extraordinary. Some not the numbers that you're referring to. They were more in the 100,000. But yeah, I mean, the idea is that when you have higher volume, and also one of the pillars is the orbital assembly, and the other pillar it's to do with how can we make this profitable, and how can we build it in a way that can be scaled up and mass produced. So most of the hexagons and the pentagons, most of the parts will be produced at scale, and that would also bring the cost down. And by having one launch, maybe a second launch for the feed out, so that's 2, maximum 3 launches compared to the ISS took 46 launches. Then you start bringing all of the costs down, which would then be passing over to our customers.
Yeah, and sorry, just to interject, we're talking about these sort of like daily rates. Some people may not be aware, but it may sound like obviously a lot of money, even like sort of the $30,000 per night. There is a number of hotel rooms on Earth which actually are more expensive than that per night. So again, sort of for like wealthy people who is probably like space tourists for the foreseeable future, this is not a lot. Okay.
We're in talks with another company that have already a clientele of about 1,500 individuals, high net worth individuals that are ready to go to space, obviously with different brackets, right? So from maybe space perspective type of access all the way to an ISS or action space type of experience.
Yeah. Okay. So let's talk a little bit about, we've mentioned a few times already, sort of other proposed space stations like Starlab, Orbital Reef. Both of them were very recently announced. Sort of the end of October, within I think a span of 4 days. And yeah, just want to give us like an overview of what the landscape is out there. It seems to be a very exciting time for space stations, which is probably substantially driven by NASA and what's called the CLD program. Do you just want to give us a little bit of background, what CLD is and why it exists, sort of, what's going to happen to the ISS, because not everybody may be aware.
Yeah, absolutely. No, thanks. And we touched upon the International Space Station briefly earlier on in the podcast. And we believe it is an outstanding feat of engineering, but it cost $100 billion to go online and about $50 billion to maintain it over the last 20 years. So it's a quite expensive exercise. And it's been great. I mean, there's been so many advances in research and technology thanks to it. But what happens next? So the ISS was originally due to be decommissioned in 2024. Now there are discussions that it's going to be taken all the way to 2028, maybe a little bit further. And what happens afterwards, right? So the US is moving, especially NASA is moving to this kind of more public-private partnership, especially with the success that they had with launch with regards to SpaceX. So they're moving to a similar model when it comes to commercial space stations. So they want to be one customer of many, as opposed to being the one that actually foots the bill of having these space stations up in orbit. And because of that, they have been collaborating with some, we believe, outstanding companies. One of them is Axiom Space. In fact, they are, without going too much detail, they're planning to launch a module fairly soon and being able to extend the capabilities of the ISS. Then you have,
and just to be clear, the module will be attached to the ISS, at least at the beginning.
Yeah, absolutely. Yeah, originally it will be attached to the ISS, and then it will become a sort of a solo flying station. And then what happened now with the commercial LEO destination program, which that we also applied, and we had some great feedback there as well, is NASA saying, okay, well, we have Axiom, but we want to know, which other company out there would like to come in and come back with some proposals. The first phase is actually to have a preliminary design review, which is, and there may be some testing as well, but it's about the technology stack, the readiness, cost, what is the business model, how this is going to help the economy, so on and so forth. And that's where Blue Origin, alongside Sierra and many other key partners, they came back with the concept of orbital reef, which we believe is sort of in some areas a similar generation to the ISS and Axiom, but they also come with inflatable. So you have slightly expandable module as opposed to just using the fairing space in the rocket. Then there is also Starlab, led by NanoRacks, also Voyager and other amazing companies as well. Mm-hmm. Similarly using the inflatable. And then you have Northrop, which we don't have a lot of information. It looks like it's still cylindrical like the ISS. And those three last companies or conglomerate of companies that I mentioned are the ones that have been awarded around $130 to $140 million each by NASA to be able to design that PRD document. Now, where we come in, and we don't see ourselves, I mean, we do analyze the market. We see all the market players, and clearly, I mean, these are companies with heritage who have been operated over some of the decades in aerospace. And when the NASA CLD came to a close, the submission date, we were 5 months young, and still we managed to submit it. There were 52 interested parties, which were narrowed down to 11, now narrowed down to 9, and we were one of the finalists. Clearly, we didn't have high hopes that we would win, considering all the other applicants. But what helped us was to build a platform to get to know all these great collaborators, to have an ecosystem fulfilling with vendors and partners all of our technology stack, and also have a relationship with potential customers as well, and so on and so forth. And where we see each other, and just to round off the answer, is we see as potential collaborators. We see that we could, with our technology, look at what happens as a next generation type of space station or next generation type of infrastructure in space. And ultimately, our hope is to be able to augment the capabilities of not only these companies that I mentioned, but also other companies that may want to have a business and operate in space.
I just want to add to this that what NASA was looking for was a very small space station, I believe 2 to 4 astronauts. And also they really put a lot of attention to have it only including proven technologies, like to be as ready as possible so they can have guaranteed that in 2030 it's going to be launched. So companies like ours and didn't have much chance with that respect because we are offering something much more ambitious than that.
And in fact, all of these proposed stations, if I remember correctly, are significantly smaller than what you're proposing, right? Or even the ISS from memory. At least in their basic configurations, I realized that I think all of them are modular. So I guess you could expand them.
Yes, it was interesting to see those kind of ambitious renders from the orbital reef, and then you see the actual proposal, which is like 1/6 of that. So they probably expected to expand in the future, but for the NASA's proposal, they needed something small.
And I think, like Vojtech was saying, it's key that they also target that. Tried and tested technology. Nobody wants to be in a situation where we have a gap between the ISS and what comes next. And I think that's why we're cheering them on. And we have so far a very good collaboration with at least 3 of the offerings. And we hope to be able to continue that collaboration going forward.
What I also find very interesting about, the ones I know a little bit better is Startup and Orbital Reef, but it's also like in there, even almost part of the names, they're already kind of hinting at really the ambition to have this as a, for commercial usage, right? I mean, Startup, I think they created this thing called the Science Park, right?
Yes.
And George Washington covers Science Park. And then Orbital Reef it's even more blatant. They're calling it a mixed-use business park, which is sort of directly hinting at sort of the desire of getting commercial customers in there. It's interesting.
Yeah, and if you see, just to complement, so they're focusing mostly on human-rated on-orbit destination, which is great. Like we said, we don't want to have a gap after the ISS. Where we come in, it's a more versatile platform, something that can scale up to provide, for example, industrial-level type of space and capabilities in space. And this is why we see it as complementary as opposed to, sort of in competition.
By the way, where does the new Chinese station come in, the Tiangong?
I think it's a forcing function for NASA and for US Air Force. Like I cannot imagine proud United States government saying, "Oh, we don't have a space station, but China does." So in this case, I think where it comes in is it will make sure that there is funding for the private space stations. That's purely my opinion. That's not based on facts.
I mean, is that a potential opportunity for you guys in the sense that we're talking about that sometimes with regard to launch services providers, right? And even satellite constellations so you have the traditional space countries which have certain capabilities, but then, maybe some up and coming, or what we call up and coming space nations, they want to have that capability too. And so they can, buy it somewhere. I mean, could you guys not go to some, emerging space nations who may have an ambition to have their own space station and try to sell your product?
That is a possibility. We have considered it, but in our internal team and also with our advisors, our alliance is to the West, especially to the US, to support their global leadership. But we wouldn't discount to be able to support other companies that are part also of the, if I can say, the Western alliance. That's the right.
I was going to say, I mean, you don't have to go to extreme strategic competitor. Sell it to an ally. I don't know, the UAE or somebody.
Oh yeah, that's for sure. I mean, I have, for example, this is early stages, but I have been contacted by the Argentinian government as well. I was born there, although I lived most of my life outside, because they also have some ambitions when it comes to space. But for us, it needs to be clear that we're in line with any regulatory requirements that the US imposes for us to be able to do trade with any entity outside the US.
Exactly. On that, is any parts of your technology sort of export controlled, restricted, or
not at this point? But definitely we will run into the issues as we get further and further into development, and it's going to be, I think, interesting for everyone, space law wise and arms export control and all these kind of new things that will become more and more important as the space economy increases in volume. I think the whole concept of space law will have to change to make it accommodate space stations like ours, or even all the manufacturing and other things.
And so, talking about strategic competitors, one of them has, this is quite well known, obviously recently tested an anti-satellite weapon and has created a lot more space debris.
Yes.
We've had multiple instances already of, near misses and actual hits on the space station of space debris, right? I think quite recently a chunk of the Canadarm was taken out or chipped off at least by space debris. I think we had a few instances already where the ISS astronauts had to go over sent to the lifeboats just in case. I mean, your sort of orb 2 or 3, I forget now, but your ultimate orb is an even bigger target, so to say. How are you thinking about the sort of like the whole increasing space debris danger? Are you going to, for example, go to a different orbit where there's maybe less danger, or is there a certain type of protection, or how are you thinking about that whole topic?
Yeah, there's like no ultimate way how to deal with this. When you look at ISS, the solar panels, even they are full of little holes. That happens. On the other hand, humans developed a very good technology to protect kind of the important part and the pressurized vessel called Whipple shield, which can generally there is hundreds and hundreds of holes on the ISS, but never a single one penetrated the pressure vessel in the 20 years history. So we are just following the same master here, putting the same technology all around the sphere. But also it's a sphere. It offers the smallest cross section for a given volume. So in that sense, just passively, it's a lower risk. Cross section of the ISS is pretty huge. But yeah, once you have big chunks in space, no shield can save you. You have objects moving at 5 miles a second or 7 kilometers a second, and you just have to get out of the way. Hopefully soon enough, anything that's any threat will be monitored and you can predict it. But today, like there is a certain size that is big enough to penetrate anything and small enough that it cannot be detected, and that's the real danger.
And one of the companies that we're collaborating with and also looking at the potential for supporting Space Force on the Orbital Prime also treats the issue of orbital debris. Not on the smaller type of orbital debris, but sort of a spacecraft that in one hand maybe upcycled, or maybe just to be able to to break it down into pieces, to put it simply for our audience, and bring it down mass it, as opposed to leave it orbiting or just down mass it somewhere that it could be dangerous here on Earth. And that's where the Orb 2 comes in handy, because if you need to do any type of activities as such, then at least you're working in an enclosed environment, and you reduce the risk, or you mitigate the risk of any additional type of debris being created.
Fair enough. Besides the space debris, which came up because of this recent events, is there any other sort of risks or challenges that we haven't discussed, which interesting to discuss? And it could be really anything. I don't know. It could be like thermal management. It could be like life support challenges. It could be I don't know. Anything that we haven't discussed, which you think is relevant mentioning, in the challenges of designing and operating a space station?
Oh yeah, space is hard. There is no shortage of challenges from the engineering perspective. All that you mentioned, thermal management is always an issue. Life support systems. No one did large volume structure before in space with life support, so that's something that has to be kind of not developed, but utilized better, scaled up, figure out how to do the airflow and other things. I would say there is always challenges that will come, but all of them has been done on some scale. So it's not like we are entering an uncharted territory.
And I think where we have this sort of quite good energy with Vojtech and this bromance brewing is because, although I have a background in electromechanics, I'm the one that comes normally with the how can we make the business model work? How can we do it in a way that we could expand, support our customers, etc. And Vojtech is the one that comes with the fact from the engineering side of things as to what are the limitations, etc. But it's true that we will have engineering challenges. I love solving engineering problems. That's why we are going now for this orbital tech demo, which is divided into 4 phases. And effectively, like Vojtech was saying before, we're actually looking at increasing our technology readiness level. But I mean, the overall challenge is how can we make the space economy, if I can call it that way, grow, become a bustling space economy. We want to support humanity's broader access to space. We want to support humanity when it comes to lifting, if possible, heavy industry, or certainly the most polluting activities like mining that we do. And these are the things that really drive us to be able to pursue what we're doing here at Think Orbital.
And by the way, on that note, I'm just going to assume that you guys both read Gerard O'Neill, The High Frontier.
Oh, yes, I love it. I was actually also watching the documentary that came out. Yeah, I mean, and that's it. If you see the invention, which Vojtech's invention, which I think it's breakthrough, is actually really targeting that. Trying to get away from the tyranny of the spacefaring, to be able to master technology that allows to assemble things in space. And imagine a situation where we are able to capture resources from the moon, and in fact, those resources help us to be able to keep manufacturing things in space. And it is clearly so much easier to lift off from the moon than is from Earth. So there is a cyclical set of events that I think we're kind of taking that wave now, isn't it? There's just so much going on in space. And we really hope that we don't have to wait another 40, 50, 60 years to see a breakthrough. And that's where we would like to come in.
Yeah, I remember my first presentation at a conference at this topic, and my first slide literally was, this is ISS, this is where we are today. This is O'Neill cylinder, that's where we want to be, and that's where we see our future. And then there is definitely many steps in between. What's the first step in the direction? And that's where I placed the Orb2 and Think Orbital as a company. So it's literally like the first step on the way to the future that we want to live in.
I really hope one day we're going to get one of the, if Twitter is still around, one of those Twitter posts with like how it started and how it's going, and it's going to be how it started, like, I don't know, like Skylab or something, and how it's going, like an O'Neill type station. That would be really cool. But I mean, talking about O'Neill station, so I mean, one missing element, and this has been proposed in so much science fiction as well, is of course artificial gravity, and there's some, at least when we're talking about human spaceflight. Of course, ironically, if we're talking about non-human activities like manufacturing, gravity is the last thing you want. That's precisely what you don't want, right? When we're talking about sort of like sustained human presence, I should really do a completely separate episode on that. And for medical reasons, microgravity is bad in many ways. When do you think we might get artificial gravity, like a spinning type thing, or yeah?
I think when there is a demand for it. So when do we need it? Probably it would be very good to have it if we ever go colonize Mars, but it's not necessary. We can survive half a year in microgravity, but it would be definitely helpful for colonization. So in my mind, we will need or want something like that when we have some Mars cycler going around that's big enough and we can use it. But until then, exactly as you mentioned, one of the reasons why you want to go to space is because there is no gravity. So right now there is not much forcing function for that. Unless you want to simulate, do experiments in like moon gravity or Mars gravity, which might be more interesting for research, because for that you do need to be first in 0G and then have some centrifuge giving you moon gravity.
I imagine it will be a path of least resistance. So let's imagine a situation where we are not able to have a full autonomous activities of planet. So that means we have to have humans. So just looking at asteroid, if we could actually capture an asteroid and sort of mine the minerals, that could end the strip or the limiting factor we have around cobalt, for example, on Earth. And if there is sufficient interest, but we don't have sufficient autonomous capabilities or robotic capabilities to mine that, then that means we need to have humans. And if we need to have humans, then we need to actually have some technologies to be able to provide for a human-rated environment, something that can sustain life much longer than 3, 5, 6 months without having a significant impact on human health. And that's where we are within Think Orbital. We're also on some of the use cases that we're looking at. We are seeing, okay, how can this be done? How much space do you need? In fact, without having to go all the way to an O'Neill cylinder, which would be an ultimate dream for us. What are the ways we can get around this? And we have some ideas, let's say. They're not at the sort of the first stage of our technological development.
Great. So as we're winding down here on time, there's a few more questions I want to ask you guys. I mean, first question would be, what are sort of your near-term goals? What's the 2022 plan?
So we're currently in funding mode. We started about 3 weeks. We're raising $15 million. That should be enough for us to be able to go through the technology development, the launch of our orbital tech demo. We already have a number of investors have pledged. One of them already $3 million. They are interested on mining in space, so they're very keen on actually going forwards. Once that is successful, we in parallel also do site planning. We're already scouting for certain roles that we need. So effectively, in 2022, provided we get the funding, will be moving to a site, start developing the technologies, deliver phase 1 and phase 2 of our orbital tech demo, which is the manufacturing side, and also the welding, the electron beam welding activities, and then keep going through our milestones. And towards the end of 2023, early 2024, will be to finalize phase 4, which is basically to launch and commission and do the assembly in orbit.
Great. And so if there's any investors listening, they know how to find you and can reach out to you. We'll put your website in the show notes as well. And then the last couple of questions, as you guys know, I always ask. So one is, you obviously came, as we discussed at the beginning, to do this via some creative thinking and a perception of that this is something that was needed. Were there any other sort of things in space, potential business models, idea you you found and maybe still find attractive, like something you would do if you weren't doing Think Orbital?
That's an interesting question. To me, there's still so much space for doing satellites cheaper. I mean, higher chances that Starship will be successful are higher and higher every month, every year. And when that happens, I think there's a lot of space that could be commercially successful to have satellites that are fraction of a cost. They are not as mass optimized. But to me, this is something that, is the future as well.
We have to take also our drive. And why do we do this? In one hand, it's I personally want to go to space. So that also implies some sort of habitable module in space or beyond. Then there is also the fact that we love solving engineering problems, and how much harder does it get other than doing stuff in space? And I also personally believe in the overview effect, and I think we're at a stage in humanity that we really need to try and make that next leap. And the overview effect from many people have gone into space have come to the conclusion that we are one with the planet, which is a small blue ball in this huge universe. We should be one with humanity, one with all living things here on Earth, and really start looking after our planet for the future generations to come. So, and I think if there was anything else that would come up that would be able to help us achieve any of those three ambitions, then we'd probably be looking at that. For now, we believe a future bustling space economy requires a space platform and requires in-orbit assembly. It requires a company that would help build the infrastructure where everything else gets built on, and that's why we're driven.
Good answer. I like that. Brings us to the final question I was asking. We have talked a little bit about sci-fi already when we're talking about Ender's Game. So let me do this a little bit different because we're talking about space stations. Before I ask you about your sci-fi favorites in general, I'm going to ask you a space station specific question. So famous space stations from sci-fi. Star Trek, Deep Space Nine, Babylon 5, Tycho Station in The Expanse. And then if you want, you can pick some other ones as well. Which one is your favorite and why?
Mine has to be Tycho Station. First of all, because I love The Expanse. And because it's huge. That's what we're going for. Kind of a little civilization within a space station.
Yeah, they seem to have good bars there, which is clearly an advantage. Vojtech?
Yeah, I'm not sure if there are any space stations sci-fi that really capture my attention. I really always love the concepts of like the Star Trek shipyards, kind of structures, large structures that you build the ships in. But yeah, they always model the space station otherwise like cities, and I'm not sure if that's what will happen. So my answer is probably none of those. It's a boring answer.
Fair enough. You can come up with something better than sci-fi. That could be the ultimate ambition. Okay, guys. Well, taking a step back, sci-fi in general, favorites?
Well, I mentioned already, The Expanse. James Corey's The Expanse. Everything from books to the Amazon series. Then also Mars is a series from Nat Geo. I don't know if you guys have seen it, but it's really nice. Mm-hmm. It's a combination between not a mockumentary, but it's a kind of documentary with real facts, and also the movie The Martian.
I mean, I'm really curious about how the Foundation series that's gonna be on some streaming service, how that will turn out, because when I read it for the first time, that's probably still one of my favorite books, Foundation series. But of course, whatever Andy Weir writes recently, like Martian was fantastic, and his new book, Hail Mary, is also great. And that's probably also going to become a movie. So I look forward towards that.
Terrific. Well, guys, thank you so much. Best of luck with the fundraising and all of the other things that are going on at Think Orbital.
Thank you, Rafael, for having us. It's an absolute honor.
Speak soon. Bye.
Bye-bye.
Thank you, Rafael.
Well, that's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can follow us on Twitter at podcast_space. Also consider supporting us at www.patreon.com/spacebusinesspodcast. If the podcast got you interested in learning more about the business opportunities in the space economy, check out my new online course on space entrepreneurship on udemy.com. The link is in the episode description. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. I look forward to seeing you for the next episode.